The final product for this video is a Godot project in which the player can use the arrow keys to move a sprite around the viewport. The camera will follow the player as they move, but it will stay within the world bounds if the player gets close to the edge of the world. At minimum, the sprite will move one tile at a time. If an arrow key is held down, the sprite will smoothly move until the key is released, at which time the sprite will come to a stop in the center of the closest tile. Collisions will be implemented in a later video, so the sprite can currently walk on water. We start this video with two tile maps, a regular tile map containing green tiles representing grass, and an Autotile map that contains water tiles. If you want to learn how to get your project into this state, watch the video linked in the description below. Add a node 2D and name it player. Add an animated sprite as a child of player. Create a 16 by 16 pixel player character. Save the character in your Godot project as character.png. Select character.png in the Import properties. Uncheck Filter and click Re-import. Select the animated sprite. Create new sprite frames. Click the folder icon. Select the character image. Adjust the animated sprite so that the root of the player object is at the top right of the sprite. This is done so that if the position of the player is set to 0, 0, the player sprite will render in the center of the 0, 0 tile on the tile map. Observe we can now drag the player node around, and the root of the player object will always be located in the top left corner of the tile the player is in. Select player and click the script button. Add a script called movement.gd to the player node. Uncomment the process function. The function called _process runs once per frame. Add an if statement to detect if the up key is pressed. Inside the if statement, add code that adds a 2D vector to the position of the player. If the up key is pressed, the player will move in the 0, -1 direction, which is toward the top of the screen. Click Project. Select Project Settings, Input Map. Add an action called Up. Click the plus button. Select Key. Add the desired key that will be recognized as Up. Preview the game. Observe that pressing the correct key causes the player to move up. Let's add code and bindings for the other movement keys. Observe that the player can now move smoothly in all 4 directions. This is one type of movement. However, in this video, we want the player to always land in the center of a tile when they stop moving. Add a variable called tile size and set it to 16. Observe that the player now moves very fast over the tile grid. Every frame that an arrow key is pressed causes the player to move 16 pixels in the given direction. Change the key detection code to isActionJustPressed. This will fire the code once on the first frame for which a key press is detected, but the code will not fire again until the key is released and pressed again. Observe that the player will now move by one tile at a time, but the arrow keys must be pressed repeatedly to get the player to move by more than one tile. The player does not continuously move while a key is held. Let's write the code that will smoothly animate the player from tile to tile. Create a variable called current tile. In the _ready function, set the current tile to position. Current tile will now be the pixel coordinates of the player rather than the XY coordinates of a tile in the tile map. Create a function called positionToTile. This function takes an argument of pixel position and returns coordinates of a tile by dividing the position by tile size. The result of the division will automatically be rounded down to the nearest integer. Change tile size from 16 to a vector set to 16 by 16 so that the division operator works. Logging the current tile now gives us the tile coordinates for the tile that the player is currently standing on in the tile map. Placing the player at tile 0, 0, we obtain evidence that our code is working correctly. Let's create a function called movePlayer that will smoothly move the player to a target tile. Replace the position-based movement code with calls to movePlayer. As an argument to movePlayer, we add a direction to the current tile the player is on to create a target tile for the movement. Add a tween node as a child of the player node. Search for Godot tween in a browser. Copy and paste the example tween code from the Godot example usage. Set self as the object that the tween is referring to. Leave position as the tween property. Enter tile2position current tile as the start location. Create a function called tile2position that multiplies the given tile by tile size to convert a tile coordinate to pixel coordinates. Enter tile2position target tile as the end location for the tween. Set the tween duration to 0.5 seconds. After the tween is called, set current tile to target tile. Preview the game and observe that the player smoothly animates, but if a key is pressed before the tween finishes, a new tween begins and the player glitches forward. Change is action just pressed to is action pressed. Observe that the player moves very quickly, because movePlayer gets called every frame that a movement key is held down. We want to prevent movePlayer from being called when the player is in motion. Wrap the input code in an if statement with a not is moving condition. Add an is moving global variable. In _ready, set is moving to false because the player is not moving when the game first starts. On the first line of movePlayer, set is moving to true. Select the tween node. Click Node in the top right. Click Tween Completed. Connect this signal to the player node. A function was added to player that will receive a signal, or in other words, get called, when a tween completes. Inside this function, set is moving to false. Is moving will now be true while the player is moving from one tile to the next, and no new movement keys will be accepted during this time. When the player reaches their target tile, the tween will complete, is moving will be set back to false, and the code will again start listening for a movement key to be pressed. Reduce the tween duration from 0.5 to 0.2 to speed up player movement. Let's make our map bigger. Select the grass tile map. Click the copy icon. Click and drag to copy the grass tiles. Click to paste 4 sections of grass tiles. Select the water tile map and draw more water tiles to cover the new grass. Observe that the camera does not follow the player off screen. Add a camera 2D node as a child of the player. With the camera node selected, check Current on the right side of the screen. Observe that the camera now follows the player, but the camera shows part of the screen that is outside our world map, when the player gets near the edge of the world. Select the camera node, set the left and top limit to 0. Observe that when the player is dragged around now, the camera stays in bounds. Select one of the tile maps and hover over the bottom right tile. Read the coordinates of the tile in the bottom right. Since the top left tile is 0, 0, this tile is one more than what is shown, so 40, 24. Set the right limit to 40 times 16. Set the bottom limit to 24 times 16. The camera now stays within the bounds of the world. The player now moves along a tile-based grid in the world and the camera follows the player. If you want a grid effect as shown at the beginning of this video, edit the sprite used for the green grass tiles to have a border along the right and bottom sides. Check out the description for more videos.